Hi everyone, welcome back to the channel. Today we are going to talk about variables. But first let's see how exactly variation in the data arises. There are two reasons that causes data variation. First is the inherent variation in the population, like people obtaining different test scores or individuals with different heights and weights. Even the amount of people residing in different area also varies. This is what we call population based variation in data. Another kind of variation is measurement based. Many a times you might have noticed that different weighing machines show different weights. It has happened to me a few times. Once a machine showed me 5 kg less weight and I was so happy. Anyways, this is called instrument or machine based variation. Also, the variation can come up due to measurement done by different people. Once, me and two of my friends were measuring the width of a wall. I know it seems odd, but we were just doing it for fun. And we all came up with three different results, even when we were measuring with the same measuring tape. Our readings were off by a few centimeters, but still. So, this is also a commonplace occurrence. Yet, this measurement based variation can differ by 1 or 2 points or as much as 5 points as well. So, when we are designing the experiment, what variation are we taking into account actually? It is the population based variation that we take into account, and the trait that we are measuring is called random variable. Let me explain. Suppose I want to measure the effect of running time on weight. Here, I will already specify some constant time points such as 10 minutes, 15 minutes, 30 minutes, 40 minutes, and 1 hour, so on and so forth. And at the end of 1 month, I want to measure the weight of the individuals taken into study who has run at different time points. So here, weight will be my random variable. Now, another kind of variable you might have heard of is a confounding variable. This is a variable that is not the part of the study but impacts it in a serious way. For example, let's take the previous study. Now, in addition to the running time, a person's diet can also affect the weight, but I have not taken that into account. This can negatively impact the study. For example, I might get the results that people who are running for more time have more weight. That's why, while designing the study, ensure this that nothing else except the condition you have planned affect the random variable. Since I'm going to discuss probability distribution in the next video, I thought I should give a brief introduction to probability as well. So, in a basic language, probability means how much chance there is for an event to occur. You might have heard that there is 40% probability that it will rain today. That means 40% chance. So, it can be interpreted that if we set this statement for 100 days, then out of those 100 days, it will rain for 40 days. The most common example for easily demonstrating probability is flipping a coin, where there is 50% chance to get heads and 50% chance of getting tail. That is, 1 by 2 will be the probability that we will get heads or we will get tail. So the general formula for calculating probability is simply dividing the number of outcome for a desired event to the total number of outcomes that can happen. So let's say I have a deck of cards where if I randomly pick a card where each card would have equal chance of being picked, then the total number of outcome I can get is all the 52 cards. But since each card have an equal chance of being picked, then all 52 cards would be picked at least once out of 52 different outcomes. Therefore, if I want ace of heart, then the number of outcome for that will be 1. And the probability that I will pick ace of heart will be 1 by 52. And this will go for every other card. That's it for today. Thanks for watching. If you learned something, then like, share and subscribe to the channel.